Okay, so just to remind ourselves about how to rationalize the denominator, we were talking about this last time. So let's first start with the division property. So this is the same thing as the square root of 25 over the square root of 2. Right away, do you see anything that can simplify about that? Oh, because that's a perfect square. So the square root of 25 is 5, is the whole number 5, divided by the square root of 2. So it's always best if we can first simplify, and that will help us to decide now what is wrong with this fraction. Yeah, we don't want to have the square root of 2 because that's irrational, and we want to rationalize the denominator. So to rationalize it, we're going to multiply by the square root of 2 over the square root of 2. Why am I multiplying by this, and why is that a legal move? Why can I do that? I'm multiplying by 1, so I'm not changing the value because the one property of multiplication, the identity property, is if I multiply by the same thing over itself, I'm multiplying by 1, so I'm not changing the value. Why did we decide square root of 2? Yes, because that's going to become the square root of 4, which is the same thing as 2. 2, right? Because the square root of 2 times itself, or squared, becomes 2. It would have been the same thing as the square root of 4, which is 2. So the idea here is that we want to have a rational number. Now, if I multiply the numerator, I have 5 times the square root of 2. And we call that rationalized. The denominator is rationalized because the denominator is now a rational number. Okay, we're going to do literally the same thing over here. So let's start out with the square root of 27 over the square root of 5. Before we go further, I would suggest, we are going to be multiplying by the square root of 5 over the square root of 5, but can we simplify the square root of 27? What perfect square is there in there? 9. 9 times 3. So we have, this is the square root of 9 times 3 over the square root of 5, which, how does that simplify? 3 radical 3, right, over the square root of 5. Do you see how I got to that point? I'm not all the way done yet. Now, this was just this part was simplify. Right? Now, once I take this, since I need more room, I'm going to come back over here. This part is going to be rationalize. Rationalize denominator. 3 radical 3 over the square root of 5, or we can call it radical 5. What am I going to multiply the numerator and denominator by? Not 5, square root of 5, right? Because the square root of 5 is not the same thing as 5. It's like 2 point something. Okay, so now 3 radical 15, perfect, over, which is 5. Yes, you could write radical 25, but ultimately you want to get to that point of just 5. Okay, are there any on the group work that you would like to see before you start the group work? Are there any examples that you think look particularly challenging? We can always come back to these as well. Let's go on just to the next page just to talk about a few other things. So before we were talking about estimating square roots. Now we're just going to use the calculator to talk about how we would find them on the calculator and round. So the square root of 10 is going to be a little bit more than 3, right? Because the square root of 9 is exactly 3, the square root of 10 has to be a little bit more than 3, but it's irrational, so it's going to have a decimal value. If you take any calculator and you turn it on, this one just appeared, so I'm going to try it out on here. It's always fun to find the square root on different calculators. Here's my square root button here. So if I push the square root and I press 10, enter. Now, a lot of your calculators are giving it back to you exactly. They don't want to round it off, okay? So you have to figure out a way on your calculator to estimate, to approximate. I used to know how to do it on this calculator to approximate. Oh, let's see. Well, actually, I don't. So let me just get out my regular calculator. So that might take me too long to remember how to do it on there. Okay, so here's my other pink calculator. So I'm going to take the square root. There's how I do square root. Because the square root is in the second position, I have to do second, then x squared. I'm going to type in 10, and now I get 3.162. If I want to round that to 3 decimals, 3.162, why am I leaving that a 2 instead of rounding it up to a 3? Yeah, because the next number is a 2, so we round down, which means we leave it a 2. And we can use the wavy equal sign for approximate. Okay, for this one, I'm going to go 1 minus the square root of 17. Tell me, just when you see the square root of 17, what number comes to mind? The square root of 17 is a little bit bigger than, yeah, because a little bit bigger than 16. Since the square root of 16 is exactly what number? 4. That means the square root of 17 is a little bit more than 4. 3 minus a little bit more than 4 is negative 3. That makes sense. 3.123, rounded to 3 decimal places. If your calculator is not showing it, bring it to me and I will try and figure out why it is. On those other ones, I know that. You have a question? Oh, negative. Yes, negative. Sorry, I forgot my negative sign. Okay, for this calculator, in order to get the approximate, what you actually have to do is you have to change the mode. So if you click mode, scroll all the way down to classic and push enter. Math print means it's going to give it to you exactly. There's another way too, which is this double arrow. So now I'm going to go second quit. Now if you try it, 1 minus the square root of 17. There you go. Oh, fixed. Okay. Okay, here the square root of 18 divided by 2. Now again, the square root of 18, let's think about it mentally. What number do you expect the square root of 18 to be? A little bit more than 4. A little bit more than 4 because again, square root of 16 is 4. So this is a little bit more than 4. So on my calculator, if I go the square root of 18 and I push enter, that's not the number I want, but I was just going to prove to you that it's a little bit more than 4, 4.2, right? Now if I go divide by 2, what that does is it takes the last answer and it's dividing it by 2. That's what the ANS means. It means take the last answer and divide it by 2. And so we get approximately 2.121. None of these we've had to round up so far, right? Does everybody understand why we leave the last digit a 1? Why is it? Tell me. Yes, the 3 is below 5. Good. Okay, next one. Now here's something that's really important about this one. Negative 2 minus the square root of 50 needs a parentheses in the numerator. If you're going to do this all in one step, you would need multiple parentheses. So I'm going to show you, you can break this down one step at a time, or you can do it all in one step. If you do it all in one step, you need parentheses around the numerator, negative 2 minus the square root of 50. And now notice how my calculator already puts a open parentheses there. I need to close that parenthesis, and I need to close the front parenthesis before I divide by 6. Okay, so if you didn't get approximately negative 1.51, what would be the next digit that I would write 3 decimal places? 2. Does everybody understand why we rounded that 1 up to a 2? Because its next door neighbor was an 8. 8 says go higher, right? If you were going to do this in 2 steps, you could just do the numerator and then go, so we would go negative 2 minus the square root of 50, enter. Okay, that's negative 9 point something. Then we could go divide by 6. That's going to take that whole entire answer. You see, I get the same exact answer. It's just I did it in 2 steps. You just have to make sure with these fractions that have a lot going on in the numerator that you have enough parentheses. Okay, a lot of times if you're getting the wrong answer, is because you don't have enough parentheses. So you might as well do it in multiple steps in that case. You see what I'm saying? And you could do that in order to check. Okay, so for the next two, does anybody know why we're going to talk about simplifying these right here? Does anybody know what these look like? And this is only if you've learned this before. Some of you have learned something before, and this looks familiar. Quadratic formula. We haven't done quadratic formula yet. We're going to do it in like 2 days. Okay, but actually, I think we're going to do it on Thursday. But when we we're going to get answers that look like this, because the reason why we do the quadratic formula, and we're going to talk about it, like I said, on Thursday, is because we cannot factor. When things are factorable, we will get answers that are rational, like we did when we were factoring to solve, right? Even when we got a fraction 11/4, that's still rational, because it's a ratio. It's a comparison of two numbers using division. We call this number the square root of 12 irrational. Why is the square root of 12 irrational? Because it's not a perfect square. If we take the square root of a perfect square, we get a rational number. But we can still simplify this. So here we're going to get 4 plus or minus. Can you simplify the square root of 12? Yes, 4 times 3. And you specifically chose 4 and 3 because 4 is a perfect square. You didn't choose 6 and 2, even though that multiplies to 12. So this is our perfect square. What happens to that perfect square? It comes out as a 2 radical 3 over 2. Now, it's really, a lot of times students in this situation, they want to just cancel this. But what you have to realize is that this plus or minus in between literally means we have two answers. It literally means you have 4 plus 2 radical 3 over 2, and you have 4 minus 2 radical 3 over 2. You have two solutions. That's what that plus or minus means. But the 2 is dividing into both things. So remember, there's an implied parentheses in the numerator. So if I divide them both by 2, that means 2 is going to divide into the 4, and 2 is going to divide into the 2 radical 3, but it doesn't divide into the 3, it just divides into the coefficient, right? It divides into both. So if I reduce this down, what can I get? I'm going to divide 2 into both of these. 2 goes into 2, or 2 goes into 4, 2 times. 2 goes into 1. So this becomes 2 plus or minus radical 3. That would be its most simplified. Here, 2 minus radical 3, and here would be 2 plus radical 3. So what I just want you to see is those are two different numbers, two different answers. Okay, and again, when we get to working with the quadratic formula, it will look like this. This will be the answer, and it won't have been fully reduced, and you have to go through this process to reduce it down. Okay, what about the next one? The square root, so 16 plus or minus, let's simplify the square root of 27. What perfect square can you find in 27? 9 times 3, okay, over 3, which is equal to 16 plus or minus, what happens to the 9? It becomes a 3 radical 3 over 3. Now here, because again, this whole thing is in parentheses, we would have to, multiply this in order to add. So it's going to have to be approximated because this is an irrational number. Even though the 3 divides into the 3, it doesn't divide into the 16. So the only way, if you really, really wanted to reduce these, you could say 16 over 3 plus or minus 3 radical 3 over 3. But 16 over 3 doesn't reduce, does it? So it's just would have to be 16 over 3 plus or minus radical 3. Realize if I wanted to add these back together, I would need a common denominator, which is where we get that 3/3 from. Do you see what I'm saying? So you can see this either way. I would actually count this. This would be fine as simply reduced, or this is the same thing. Either one these are equivalent to each other. So it's just being able to recognize those two forms, okay? So now we'll have you guys go ahead and try the group work.